Here we have another AP Calc example featuring this world famous object that moves along a straight line, and what they're telling us is that at any time such that t is greater than 0, the velocity of that particle is given by this equation here. And they're asking us what is the distance traveled by that object from t equals 0 to the first time that it stops. When we go to find distance traveled is going to be an integral setup. And when we go to find it, to get the distance traveled, we're going to take the integral of the antiderivative of our velocity equation. So we're going to go the antiderivative of the cosine of 3t dt. But we need bounds on it because we're going to be looking to get a number out here. Well, we know the lower bound. The lower bound is 0. We're starting from that point, and then they want to know when it hits the first time it stops. That's going to be the upper bound. Well, how do we figure that out? We've got a velocity equation, so when something stops, that means its velocity equals 0. So what we're looking for is when does our velocity equation, when does the cosine of 3t equal 0? And now is when you got to bust out your unit circle knowledge. So if we pull out our unit circle, the zeros on unit circles are always happening at our corners here, is what I call them, at these edges. So this is at 0, that's the point 1, 0. At pi over 2 up here, you've got the point 0, 1. At pi, you've got the point negative 1, 0. And then down here at 3 pi over 2, you've got the point 0, negative 1. And then we get back to 2 pi and we just repeat that process. Well, why do those corners matter? Well, because the x and the y values on any point on the unit circle come from the cosine and the sine values. The cosine of our angle is going to give you the x value always, and the sine value of your angle is always going to give you the y value. So as we look at this problem right now, what we know is we're starting here at 0. They told us that to begin with. And what we're looking for now is when is the next place, when does the velocity equal 0, when would cosine equal 0? So we need to find out when would the x value, when's the first time we're going to run into that x value equaling 0, because that's when the cosine would equal 0. So as we come through here, we can see that the first time following this circle that we would run into 0 would be right here at pi over 2. So what you need to have happen is we need this inside piece here, 3t, whenever that equals pi over 2, that's going to be when we run into a velocity of 0. That's when we'll be stopped for the first time. So it's not pi over 2, remember, because this is a 3t going on inside here. So we need to know when would 3t equal pi over 2. And to get that, we just solve that for t. We would multiply by 1/3. We multiply by 1/3, and we would get t equals pi over 2 times 3 is 6. So that is now going to be our upper bound on our integral that we're taking over here. So from there, we go to take the antiderivative of this, and when we go to take the antiderivative of a trig function, these are what I refer to as special case antiderivatives. They're antiderivative rules that you just have to have memorized. If you have them memorized, it's quick and easy. If you don't have it memorized, you may not guess it. So from there, the antiderivative of the cosine of a number times x works out to be 1 over whatever that number is inside there, and then cosine turns into sine of ax, and when we've got no bounds it would have a plus c, but we've got bounds so we wouldn't get that. Looking at our example, the a value is going to be 3, so we're going to end up with 1 over 3, and then this will be the sine of 3, I guess we're talking t's here, so this would be the sine of 3t, and then evaluated from t equals 0 to t equals pi over 6. To finish this up, this is what I just call top minus bottom from here. So we're going to do top minus bottom. We're going to take now, and we're going to plug the top value into our equation and subtract off the bottom value plugged in. So plugging in the top value, we get 1/3 sine of 3, and then instead of t, we have on the top pi over 6, and then we're going to subtract off of that 1/3 times the sine of 3 times 0. So we clean this up a little bit. We've got 1/3. This would be the sine of the 3 and the 6 will simplify down to being pi over 2 minus 1/3 sine, and then 3 times 0 is going to be 0. So lucky for us, we already have all the info for our unit circle laid out from the work we did earlier. The sine of pi over 2, that is going to be the y value at pi over 2. The sine of pi over 2 is going to be 1. So out of there, we are going to get 1/3 times 1 minus, and then we're going to get 1/3, and then this time we want the sine of 0. So at 0, the sine value, again, the y value is what we're looking for, would be 0. And so this would be 1/3 times 0. So out of here, what you're going to get is 1/3 times 1 gets us 1/3, and then 1/3 times 0 is 0. So 1/3 minus 0 leaves us with 1/3. So this would be option C. So the key on this, again, was probably more unit circle based than actual calculus based, but whenever you want to get the total distance traveled, you're going to be taking the antiderivative of that velocity equation. Thanks for watching my video. If you liked it, please click that like button and subscribe, and also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.